Well, welcome everyone. I want to welcome you to the October Academy program of the North American Unitarian Association. The NAUA is dedicated to supporting and promoting the practice of liberal religion by embracing freedom, reason, and tolerance, rooted in our commitment to the inherent worth and dignity of every person and all peoples. The Academy offers monthly programming during the academic year on issues of concern in our society from a liberal religious perspective. My name is Joyce Francis. I'm a member of the NAUA Academy Advisory Board and hosting you today. I'm joined by Terry Anderson, wave Terry, who is managing the technology for us. I'm joining you from Port Townsend, Washington, and if you're willing, I hope you will add your own location after your name, as I have done. If you don't know how to do that, you can ask in the chat and one of us can help you. We can fix it. Just tell us where you are. We're becoming an international organization with new participants and members joining from South America, from Europe, and it's interesting to see the geographic spread of our audience. You can rename yourself by clicking on those three dots next to your name in your picture and or in the participant list in the upper right corner, and there will be a choice to rename yourself and add your location. Today, we have a returning presenter, Dr. Mark Reimers, the chair of the Academy Advisory Board, who will be speaking on the science of consciousness. Mark is a quantitative neuroscientist researching how dynamic brain activity gives rise to thoughts and feelings. He has worked at the U.S. National Institutes of Health, the Karolinska Institute in Stockholm, the Virginia Institute for Psychiatric and Behavioral Genetics, and at Michigan State University. His broader aim is to ground our understanding of feeling and thought in brain dynamics and biology. He was the leader of the Richmond Humanists in Virginia for 5 years and the leader of the UU Forum in Lansing, Michigan for 6 years. He speaks frequently at humanist and science outreach events in Michigan and online, and he aims to weave together brain science with humanist ideals. You'll notice we're recording this presentation, which will be roughly an hour, and it will be available soon on the NAU website, naunitarians.org. While he's speaking, I ask that you remain muted. For those who are joining us live after his presentation, but during his presentation, there will be brief times when we will break out to smaller groups. But at the end of the presentation, we'll stop recording and move into a general discussion. So Mark, with that done, I leave you with the program in your hands. And if you would
Thank you, Joyce.
jump in.
Welcome, everyone. Let me start by sharing screen here. And I think we're ready to go.
Yes.
Can you all see?
Looks good.
Yes.
Good. So when you think about consciousness, what questions do you have? I'm going to try to address 3 questions. I'm not going to answer them. There'll be no final answers in this session, but I'd like us to keep in mind these questions as I outline what little we actually do know about about consciousness from the point of view of science. I'll do that in 3 parts. Part 1, I'll be trying to unpack what do we mean by consciousness. And then I'm going to ask you to think about, are animals conscious? Probably most of you have beliefs one way or another. Why do you believe those things? Part 2, I'm going to talk about what happens when you wake up from sleep or out of anesthesia and how you become conscious in that sense. And then I want to talk about consciousness as, well, maybe a bit like a government. And then I'll turn it back to you and ask you, is consciousness something that's made by the brain, or is consciousness something that's transcendent, that pervades time and space? And in part 3, I'll be talking about why consciousness seems to be so active and so personal. Then we will turn to discussion, and that will take about a little over an hour. I hope you can stay. So let's start with what we mean by consciousness. What is consciousness? Well, many people think they can define it at least to their own satisfaction. I've heard hundreds of very confident definitions from various people. None of them are the same. If we look at the world leaders in thinking about consciousness, from John Locke, who introduced the word in the modern sense to English in 1690, down through Jean Piaget in the 1950s, and I'll be sharing some ideas from more recent studies. All of these look very intelligent, but none of them look to overlap very much with any of the others. These are all people who really thought about this carefully. So I don't think we can necessarily come up with a definition that's going to satisfy everybody for all time. So what do you and I mean by the word consciousness in everyday speech? Well, I think we should start by noticing that people use the word in different contexts, and in these different contexts, it may mean very different things. So we certainly use it to talk about waking up in the morning. I'm conscious. How many of you say that? We can also say that we're aware of something, that we noticed something. I was conscious of his state of feeling. We can talk about it in terms of attention. I'm conscious of the airflow in the room. We certainly can talk about it in terms of self-awareness. I'm conscious of my own failings. In that sense, it's akin to the word conscience, and the relationship is actually quite close, as I'll show in just a minute. We also use it for an inner dialogue. And when we're sort of weighing the merits of one course of action or another. And we also use it vaguely to talk about the story we're telling about our lives, our consciousness, our life story. So all of these different senses of the word conscious or consciousness can perhaps be related to brain activity or to something we can study scientifically. But there may not be a single process, a biological process, that underlies them all. Let's keep an open mind about that. There's probably some commonalities, but if we can't define consciousness, we're not necessarily going to find, a nice, simple biology behind it. It's a recent word in English. That's part of the problem. The Reformation thinkers talked a lot about conscience, about how they following their conscience in breaking away from the Church of Rome. And that seems to have spawned the first appearance of consciousness or conscious in English about the beginning of the 17th century, where it was more or less a synonym for conscience, a private awareness of one's own actions or moral failings. John Locke, as I mentioned, was the first person to use the word in the modern sense in the English language, although Descartes used it a little earlier in Latin. And we can see that as the word conscience has decreased in the past century and a half, the word consciousness has taken over. That may mean several things. It may simply mean that we have a shift from a more religious or social understanding of ourselves to a more secular and individualistic understanding of ourselves. But certainly the words are linked and related. We'll come back to that. So you might ask, well, if we can't really define what consciousness is very precisely, how can we study it scientifically? Well, this has been a problem that's occurred to many leading scientists, and in particular, Francis Crick. You may remember him as the co-discoverer of the structure of DNA. Well, he was a major force in DNA science for more than a decade after that discovery. And then finally, in the 1970s, he decided, I really want to study the brain. I want to study consciousness. He'd already won the Nobel Prize. He was already, famous. What you can do when you win a Nobel Prize, you can do anything you want. And he decided he wanted to study consciousness. And what he proposed was to study what he called the neural correlates of consciousness. What does that mean? So remember, he's not talking about the neural cause of consciousness. We don't know what that is. We don't even know how to ask the question, but just saying what happens in your brain when you're conscious, at least in one of the many senses, and you compare that with what happens in your brain when you're not conscious under the exact same conditions insofar as we can make them. So if you are in a room with a breeze and you are conscious of the breeze, how's that different from when you're in the same room having the same kind of conversations with the same breeze, but you're unaware of it? What's different? Okay, so let's start with one of the kinds of tests that's done here. I'm going to talk about conscious perception versus subliminal perception. I think you've all heard about subliminal perception. So we can see something without it registering, without being aware of it. So I'm going to show you a creature that's not very conscious, at least we don't think so. And I'm going to ask you a question. How many of you saw the bird? Anybody? Put up your hand. Okay, Joyce did, and Joanne did, and Terry didn't. Okay, and Ellen did. Okay, great. So several did, some didn't. If I had done that a little faster, probably about half of you would have seen it and half of you would not have. It looks like about half of you put up your hand anyway, so that's maybe it was the right speed. But basically, when you show, let me play those again. When you show things in rapid succession, you may not register that something different has been shown. So that's a sort of the meaning of the conscious perception. Now, that's not usually done with pictures of animals. It's usually done with words. So let's do the same thing now. Look at the word Albert. This is much more boring, which is why I didn't start with it. But this is what the subjects in these experiments do. So we have Albert. How many saw Arthur? Again, probably if I'd done it a bit faster, not so many of you would have seen it. So that's an example of the kind of test you can do. You can show a subliminal stimulus, or maybe play a recording, an audio recording of a subliminal stimulus so quickly that it gets masked by what's before and what's after. And sometimes you see it and sometimes you don't. So what happens in your brain when you see it as compared to when you don't? So we've tried to make the situation identical. Everybody's getting the same stimulus for the same time. So what's different? So I'm going to show two sort of animations of the human brain activity, and I'm going to indicate activity by a reddish coloration. And for now, I'm going to ignore any activity that doesn't have directly to do with seeing those words or seeing those pictures. So On the left side is going to be a representation of brain activity when you see something but you don't perceive it, you don't notice it, it doesn't register. And on the right-hand side, I'm going to show brain activity when you become aware of it, when you can say, yeah, I saw something. So what's different? And I'll show you expanded what happens in about the first 1/3 of a second. So I'm going to play this slowly, this animation slowly. So we're going to start with just after you've seen the picture and your visual cortex, which conveniently is at the back of the head in the most awkward position possible. Well, that's evolution for you. Uh, the That visual cortex is activated slightly, and let's see what happens next. So left is the brain subliminally perceiving. The right hand is the brain becoming aware. So there's more activity. You can see it's a little bit stronger in the aware case. And then what's really different is that in the subliminal case, the activity in the visual cortex fades out. Well, it's also starting to fade out in the aware case. But what's really different is that you see some activity in prefrontal cortex up here. And then that activity reactivates the visual cortex. So you're getting a sort of reverberation effect. And this happens actually several times in a second. So in the time that it takes you to even think, I've become aware of this, there's a back and forth many times, several times at least, between your visual cortex, which is doing the perceiving, and your prefrontal cortex, which is sort of preparing you to recognize. And this is what people call a global workspace, meaning that there's coordination and reactivation between specialized regions with different specialties in response to the same event. And some scientists, in fact, the originators of this idea, like to think of it as a kind of global workspace. All of the parts of your brain are working together on addressing or being aware of this particular event. Okay, so I'd like to stop there for just a second. We'll go to breakout rooms in just a second. And I'd like you to think about a particular question and discuss this question. Most of you either have pets or you have had pets in the past. Do your pets have some kind of conscious experience? This is deliberately, of course, provocative. And here are the instructions. So I'd like you to take a minute, try to do this first in a minute, say what you think, do they or don't they, and give one or two reasons for your belief. Try to finish with a sentence about some aspect of your reasoning that someone else might not find convincing. If you can't think of it, that's okay. I'm sure someone else will. And then you can listen to each other. So go through a group of, I think we should try for 4 per group, but maybe we'll have some groups of 3. Listen to each other, and then try to respond. I'd like each of your groups to appoint a timekeeper to try to remind people when they've gone beyond their minute. Okay. We all have lots to say. Let's try to keep it to a minute and appoint a timekeeper. And then afterward, Joyce, if you would call on a couple of people to give a just very brief summary, 30-second summary of any interesting points in their discussion. So again, if you think you've had an interesting discussion, appoint somebody as a spokesperson. Okay, ready to go? Quick question from Deandra.
Yeah, Mark, thanks. Can you elaborate which definition of conscious you want us to think about for cats and dogs? Are you thinking about whether they're aware or unaware, or are you thinking about whether they're like self-reflective? Or could you just elaborate what you're asking us to consider?
Well, I'm asking you to consider any of the common definitions and one in which you particularly believe has a relevance to cats and dogs. So pick your definition to some extent. I think you probably won't get very far with self-reflection or philosophy, but I think you might get far with some of the others. Okay, so let's maybe pause there. And Terry, if you could put people in breakout rooms, then we can take it from there.
I cannot measure it. That every time I've thought animals can't do something that I can do, eventually I'm proven wrong.
Thanks for that. Uh, somebody else who wants to speak for their group, if you would raise your hand, please.
No. Let me see.
There's David.
Was Carol waving her hand?
How about if I
No,
call
I
on someone
Oh.
then?
Would anyone like to summarize an interesting discussion that their group had? Please go ahead, Joanne.
Joanne. Hi, Joanne. Let's hear
Hello.
from you.
So we had a really interesting discussion. We didn't really disagree because all of us did feel our pets were conscious, but we had a lot of different reasons. A lot of them came down to communication. The fact that they can communicate says that they have to be conscious. I shared a story where I thought my cat had to be intelligent too, because she was more intelligent than me. I forgot to give her water and I wasn't catching on when she kept leading me to the water bowl. So she started got in front of the sink and started, clawing up and looking at me. See, dummy. And I thought, okay, so that's intelligence and communication. We also talked about being aware of the owner's mood, being able to pick up on the mood. And Alexa said, well, some people might say that's an automatic reaction to the chemicals they smell, but it seemed like it was more than that. The need for proximity, the fact that they can anticipate what's going to happen. You take out the suitcase and they know you're going on a trip and they don't want it. And then the fact that they have different personalities, because if you have a robot, you generally expect all the robots to respond in the same way. And in fact, animals do not. They have different personalities and seem to be making decisions about how they respond.
Well, thank you. Thank you. Let's hear from Gail. Go ahead, Gail.
Yeah. Our group was myself and Jen and David, and some of us are dog people. Have had cats. David had cats. My experience was that I have two dogs, Basset Hounds. One is Henry Dumbledore. He's lovable and sweet like a Basset Hound. But Virgil is the contemplative. That is his name, Virgil, contemplative. Why? Because he thinks, he watches, he absorbs, he processes, and then he reacts. And our discussion was around, how do we know our pets react to us? Well, they have memories, they remember behaviors. Jan was telling about her little puppy that was confined by her husband, and then he accidentally sneezed and it scared the puppy and he ran away. So for the rest of the puppy's life, the sneeze was a terrifying event. And we know dogs care about each other. I mean, we've all heard the story about not just dogs, but animals. The blind I guess it was the donkey and the goat, the goat and the donkey goat led the donkey to the pasture to eat every day, and the horse or donkey got stuck in the brambles, and the donkey went to get the owner to help the horse get out. So they have compassion, they think, they have memory, they respond to us, and if they're separated from owners, sometimes they go on long journeys over months, stopping and being cared for and then continuing. So yes, they have consciousness.
So it seems universally agreed. Well, I think, Lynn, we're not going to be able to hear from you this time, next time maybe. So let's get back. I know Mark has an agenda here we want to follow.
Okay,
Thank
Lynn,
you, guys.
please save your comment for afterward if you can stay on. We'd like to hear. But we're just trying to keep to a schedule here. And so let's get back to where we are. So let's consider a different kind of consciousness. Sorry, can you all see this going on?
Yes.
Yes.
Good. A different kind of consciousness, which is what happens when we wake up. So you probably know that when you're asleep or under anesthesia for that matter, your brain is not dead. It's not doing nothing. Your brain is actually quite active. It's somewhat less active than when you're awake, generally speaking. There are a few parts that are more active, especially when you're dreaming. You can, if you put electrodes on your scalp and can record yourself during waking or sleeping, the trace of those electrodes looks something like the picture on the right. If you are, say, relaxed, you're maybe reading a book or talking to somebody, or watching TV, you're going to see very small, very rapid fluctuations of voltage on the scalp. That reflects very rapid activity, and it seems it seems superficially chaotic. When you go to sleep, you start seeing deeper waves of voltage, and they're slower, so it almost looks more organized. When you're in a light sleep, you get deeper waves still, and in deep sleep, the most restorative kind of sleep, you have these huge voltage surges, the biggest that we can record in the human scalp, and they're very slow. This is representing about 5 seconds worth of actual time. So these kinds of oscillations tell you so that the brain is active, but it's active in a different way when you're asleep. So again, let me show you how that is. And again, I'm going to use two animations side by side. And on the left side will be activity of your brain when you're asleep. On the right side will be activity of your brain when you're awake, or at least one possible situation in which you're awake. This is just a cartoon, not a recording. And what you're going to see is that, so let's take a look at what's happening on the left. So you have the red again signifies a region that's very active. And you can see that as the seconds tick by, that region of activity, now again, I'm stretching out time. Let's go back here. That region of activity sort of spreads and moves and shifts. This might be happening in half a second or so. Whereas if you look on the right, when you're awake, you may have regions of activity in different parts of the brain, far apart from each other. And then the next moment, maybe a quarter of a second later, you might have completely different areas that are active. And then you might go back to the ones that were active before, and perhaps back again to the ones that were active in the second condition. And we think that these areas are communicating, these active areas are actively communicating with each other while you're awake. But as you can see, there's not much cross-brain communication. There's perhaps local excitation, local stimulation of your neighbors, of the neighboring neurons, but nothing that really is coherent. The different brain regions aren't talking to each other. They may be talking to themselves. And so this is an example of more communication and coordination between activity in regions of the brain that are physically separated, that are not sort of contagious with each other. And this kind of spreading communication depends on lots of wires communicate between those areas. And the human brain is full of wires. In fact, most of your cortex is not neurons, gray matter, we call it. It's white matter. That is the wires, the axons of the nerve cells that are sending messages back and forth across your brain. And the idea that the number and construction of the wires, the potential for information exchange between different regions, the idea that that might be the key to consciousness has been formalized as something called integrated information theory. It's really more of a mathematical metaphor. It's very difficult to actually do any calculations or predictions with it, but it's attractive to a lot of people. And in fact, that's one of the most prominent theories of consciousness today. The other being the global workspace theory that I mentioned earlier. Now, those are the two most prominent theories. There are literally dozens more. I think someone compiled them all and caught almost 100 distinct theories of consciousness. Again, it's just as many as there are definitions. The problem with all of them, and the problem with calling them theories, is that none of them give precise predictions that are confirmed by experiments. They give rather vague predictions, and when they can be tested, as some of them were tested recently, none of the theories really nail it. None of the theories really predict what is actually observed. So I think it's fair to say we don't really have a theory of consciousness in the same way that we have, let's say, a theory of gravity or theory of relativity or a theory of evolution. Those are very well worked out, detailed. They make very specific predictions about what you should see. And in fact, you do see it when you do the appropriate measurements or experiments. So I'm not going to say anything further about theories of consciousness because, to be frank, we really don't have any good ones. So we're still thinking about what it could mean. So I'm going to present some other aspects of consciousness in the hopes that this will gradually build a richer sense of what's involved and maybe give us something closer to a realistic idea, or maybe not quite a theory. But let's start with what the theories have in common. So most of the theories highlight stronger communication between distant brain regions during awareness of a perception or becoming awake. Let's take that as a theme, a common theme. Now, if we think about communication between all the different parts of your brain, we run into a physical limitation. We just can't fit all the possible wires to connect every region with every other region. So in fact, each brain region preferentially talks to 3 or 4, maybe 5 or 6, or maybe at most a dozen or so other regions. No region broadcasts everywhere in the brain, or at least very, very few broadcasts to even more than a dozen regions. And neuroscientists have been recording using MRI from human brains for quite a while, and they notice that some sets of regions are more often active with the same others, maybe during periods of 5 or 10 seconds. So we think that those regions are communicating if they're coactive, active at the same time, quiet at the same time. And we call them networks but we shouldn't think of these as, disjoint. Any region, can talk to many other regions. It may have preferred partners that it talks to more often. So let's look at one of those networks, one of those sets of regions that tends to be active together. And this network gets called the default mode, and that has a strange history. It's the set of regions that was noticed first because whenever the early experimenters asked someone in a scanner to do a particular task, they noticed that no matter what the task was, always the same set of regions would get quiet. So they thought, well, these regions that were active when the person wasn't doing anything in particular, they must be the kind of default mode of the brain. And when you're doing something, you engage other regions. Anyway, it turns out that this so-called default mode is actually active when we're having private thoughts, when we're ruminating about what went wrong or what went right today. This picture shows two views of the right hemisphere of a brain, human brain. They're slightly expanded. So you know that your brain is very crinkled. It has many, many crevices and bulges. So you just imagine that you could somehow blow it up, take an air pump to it and blow it up, just expand it a little bit so that it was smooth. Then each half of your brain, each hemisphere, would look a little bit like these two pictures, where the picture on the left shows the right hemisphere from the outside, and the picture on the right shows the right hemisphere from the left side, from looking at it from the midline. So you can see that some areas are marked in orange or yellow, and some areas are marked in blue. And roughly speaking, the default mode of the brain is when these orange areas are simultaneously active and these other areas are simultaneously quiet. And interestingly, we can identify functions for many of these regions that are simultaneously active, and they turn out to be engaged by tasks that involve social relationships and identity, group identity. And the areas that are quiet are typically concerned with making decisions or perhaps with sensing the world around you, noticing something in the world around you. And so finally, someone asked, well, what are people thinking about? And they asked people in the scanner, what are you thinking about when they showed this pattern of activity? And usually they were thinking about, some problem they had with their spouse or a child or a parent or a coworker. They were ruminating. And we think then that these regions are primarily concerned with, or at least often concerned with, long-term social relationships. And I'll come back to that in the third part of the talk. But I want to point out that these regions don't necessarily always connect directly. So I mentioned that very few regions talk to more than a handful of other regions, at least not directly. And one of the peculiarities of the human brain is that because remember I said that we have such a big expansion of our gray matter, our cells, that we can't get enough wires to fit in our heads to connect even a small fraction of them. And what the human brain has done, what evolution has done over time, is find a kind of workaround. And that workaround involves most areas of the human brain connect to one of a small number of what we call core functional regions or hubs that themselves connected, mutually interconnected, and therefore every region of the brain can talk to every other region of the brain at three nodes remove. So you can, from every area of the brain, these small circles, they're connected to the big dots, the big red dots. The big red dots are each connected to each other very strongly. And then any other region may be connected to one of those other red dots. So if you want to get a message from one part of the brain, human brain, to another, you basically have to go through, not always, but in most cases, you have to go through one of these hubs or two of these hubs, and they're constantly in communication. So they might be the source of the kind of unity of experience we associate with consciousness, that no matter what's coming in, it all seems to have come to a single point of view. We don't know whether that happens for cats or dogs, but it's not necessarily the case that it happens, because the cats and the dogs don't have quite as many hubs. They don't even have half as many hubs as we do. So they may have some unity of experience, but they don't necessarily have the same kind of coherent experience that we have. Now, all of this communication, I've been very vague about it, as though it's information, as though it's like us talking. But in fact, the brain was evolved to help the body move, to organize and direct the body to move. The basic activity of the brain is to prepare for action, and that preparation is by stimulating activity in other regions. Now, we've got a much bigger brain, so if each part of than other animals, so if each part of our brain is stimulating some other parts of our brain, that's a lot of stimulation. And that, in fact, means that the human brain runs about twice as hot as another primate brain. What do I mean by that? We consume about twice as much energy per mass. So we're running very, very hot. And one of the real problems we have is how to quench overactivity. And we suspect that at least some distinctive human mental illnesses are associated with overactivity of the mutual stimulation of the brain. And evolution has equipped us with many, many more inhibitory cells that quench the activity of all of the excitatory cells. So whereas most animals have mostly excitatory cells and just a few inhibitory cells to keep things like firefighters to douse things when they get too hot, almost half of our neurons in many regions are inhibitory cells. They're basically trying to pour water on all the shouting that everybody else is doing. And that, I think, is why consciousness seems to be vibrant. The word I like is shimmer. Some other people use that word, but it's not common. That the shimmering is this fluctuation, that we're constantly on the edge of chaos, so to speak. We're on the edge of not being able to integrate. And that is, I think, reflects the constant activity of different regions trying to stimulate other regions, but getting quenched in different amounts, dynamically fluctuating, so that sometimes we're paying attention to one thing and then to another. And we can see this in the patterns of networks that are active at any one time. So this strange looking, almost modern art piece is a representation of the dominance or high periods of high activity of 8 distinct networks in the brain, each network composed of different regions that are coactive together. And so this represents 10 seconds of quiet thinking in one person. And they've found 8 distinct subsets that are flashing on and off, mostly off. So when they're going up, they're on. When they're going down, they're off. So all of them are mostly off. And the longest that any one of them is on is about 1.5 seconds. But they're constantly shifting. And so we have these kinds of rapid shifts between different network activities where different regions are preferentially communicating with one region for a half a second, and then they're preferentially communicating with another region for maybe a quarter of a second. So they're rapidly shifting alliances, a little bit like politics when it's working well. So you remember that the United States was founded on the principle of separation of powers, and in theory, that means that we should have shifting alliances according to the issue at hand. And when it's working well, which it sometimes does, then we do see that. Okay, let me set up breakout rooms again. I think we'll be a little quicker this time, Terry. So I want to set up the hard question. Can consciousness be explained by brain activity? Or is it something transcendent? Some of you might think of the word spiritual. Is there a ghost in the machine? And again, same instructions, and I will stop this. Did you see the instructions in the chat last time? Then maybe would one of you care to present a brief summary of why you think that? I'm sure that there's another group that is pretty uniform on the opposite belief.
I think it's because of our science background. I don't know.
I just want to see who's in the other rooms.
Okay. Let's give you.
In our group, we were saying that, well, mostly this was me saying this, but we did say we think that there's something physical, but possibly, and I think Rob would explain it better, possibly more of a field. There's something beyond the physical. It doesn't have to be spiritual, but he felt like we're tapping into something that's not strictly explained by the physical. Is Rob with us? Because he explained it better than me. But my feeling was, and Mark, maybe you'll address this when we get to that point, but why would your thinking and your abilities change if you have brain damage? Or why are we affected by hormones? So many things if it isn't a physical thing.
Yes. So I guess I think you've pretty much answered you've answered your question with more or less my comments that we're very susceptible to various kinds of brain damage, and our personalities may change, and our what we think of as our essence may change quite a bit. Okay, so let's hear from a few folks. Joyce, do you want to?
Yes, I wanted to see if Lynn wanted to. We didn't get a chance to talk to you last time. Do you want to summarize your group this time, Lynn?
Oh, sure. I guess we
need to be succinct, about 30 seconds here.
Good luck. There were so many different variations. There was our own what was the question again? I've lost. I'm sort of lost somewhere. Could you just repeat the question again?
Do you think that consciousness is fundamentally brain activity, or do you think that there's some transcendent aspect transcending the material world?
Yeah, it's definitely, there's so many variations of that one. I think your own personality, how it's shaped, but also about your environment. if you grew up, which part of the world you grew up with, your parents, did you have siblings? With all of those things interacting with each other, and what even generation you grew up in. Like some of us were a little older than others in the group, so our social world will influence. So what was happening in the 1950s is a heck of a lot different than the 1970s. So there's so many different influences to make that who we are.
Thank you.
Thank you. Let's see if there's anybody else. Gail, I'm going to look for somebody else this time to report. Anybody else ready to speak? Arnold, you had something to say in our group.
John had his hand up too, Joyce.
John?
Yeah.
Okay, let's hear from John.
Oh,
Arnold found the voice button.
There we go. On
Go
it.
ahead.
So who's going?
John, are you there?
I'm here. Yep.
Good.
Sorry. Our group was, didn't really have a strong opinion on it, but we did have a couple people report that they had some sort of experience that kind of led them to believe that there was maybe something going on, with something outside ourselves. And Mark's comment on not having enough connections, not having enough space for all the connections, triggered a thought that I had based on an experience in the past, that perhaps there's more connections than we can determine right now, and quantum mechanics might have something to do with that. That we may have some sort of connection through other dimensions. And there was a research done. I just posted it in the chat. I think this is the Blue Brain group. I don't know if you heard about them, Mark, but they're speculating that there's some sort of larger set of connections than what we physically would have within our skull. So I have no clue whether it's real or not, but it's out there.
Well, thanks, John.
Yep.
And Lynn. Okay, I think we need to get back to you, Mark.
Okay. Then I'll share screen again. Okay, can you see the screen?
Yes.
Okay, so I want to now consider, whoops, where did that go? I want to now consider the moment by moment experience of consciousness, at least insofar as we can measure the kind of brain activity that brings us the more rich experience of consciousness. I'm going to use a phrase that was coined about 20 years ago called the remembered present. And that's basically referring to our recognition and assigning meaning to the things that we're experiencing in the moment. So when I'm talking to my spouse, I recognize her, I know who I'm talking to. All of the memories and associations and feelings come back to me in the moment while I'm communicating. If you are stroking your pet dog or your pet cat, you have lots of feelings and associations related to the history of that pet that have nothing to do with the specific action of stroking or the cat or feeling its fur. When you're walking to work or walking down the hallway between your office and the bathroom, you know where you are and you can recognize, you can orient yourself quite quickly. So how do you do all of these things? And how do you bring your past experiences to the forefront of your mind, but not really to the point where you're thinking actively, consciously about them, but they inform everything you're experiencing? So that we're calling the remembered present. And I'm going to illustrate again with some with a cartoon. The basic idea is that there are many areas of your brain, particularly your cortex, that receive specialized information about what's happening around you. So visual cortex in the back, auditory cortex toward the side, other cortices. And then there are parts of your cortex that are very much involved with what you're doing, where you're going right now, what you need to watch out for. Those are mostly in the frontal parts of the brain. And there's an area of the brain that you've probably heard of called the hippocampus, which is actually named for a seahorse in Greek. And you've probably heard that that's important for memory. What you may not know is that there's a constant back and forth dialogue between the hippocampus and every other part of your cortex, of course, mediated by these hubs that I talked about a few minutes ago. It's not that they can all talk directly. There's no direct connections between any of these areas, but they can talk indirectly. And they do very rapidly, back and forth, and they do it all in sync. And this happens about 4 to 7 times per second. And we think that what's going on is that as you are taking in impressions, you're walking down the hall, let's say, to your colleague's office or to the bathroom, and you are receiving impressions of the lights overhead, the texture of the walls beside you. There's this impression going in to the hippocampus, and then there's the aspects of your life experience that have occurred in the past in a similar situation. As you've walked down that same hall hundreds of times, those neurons in the hippocampus are becoming active and broadcasting some orientation information about what might be coming next to the rest of your brain. And this seems to happen about 4 to 7 times per second. So you think about if you're walking quickly down the hall, then you might cover 4 or 5 feet in a second. So basically every foot that you've covered, you have had a series of impressions and then a series of sort of recalled expectations or orientations about what's coming next. And during the input phase, we're pretty astute. If something is out of place, we'll notice it. If something something flashes or sounds off, we will notice that. During the recall phase, we're less sensitive to anything new, anything flashing or anything out of place. So that seems to give some orientation toward and perhaps meaning to the experiences you're having as you have them. But the interesting thing is that different people recruit different neurons and different brain regions in this cycle back and forth. And so they may make, we think, different meanings out of the same, objectively the same experience. And we might ask, well, why is that the case? Why do people have such different meanings to this, what looks to us as an observer to be the same experience? And we don't have a complete answer to that, but I think one key ingredient is the role of the social brain in our consciousness. And here is where I think we really diverge from the consciousness of other animals. So if we compare our brains, so in the right-hand side of this figure, to the brain of our closest relative, the chimpanzee, on the left side of the figure, And again, these are MRI images, so no animals or people were harmed in making these pictures. These are virtual images, what you would see if you could cut the head in half lengthwise. And you can see that our brains are more or less the same shape, although considerably bigger. But some regions have grown all out of proportion. And in particular are some of our regions in the sort of right behind the eyes, front and center, and lower down. And we call lower down ventral, and we call toward the center medial. So these are ventral and medial prefrontal brain regions. And they've grown much more, all of our brains have grown, but these regions have grown much more than proportionally. And it turns out that they function kind of in humans as a hub. They're connected to lots of other regions in the prefrontal areas and also laterally in areas to do with object recognition or personal recognition. Let's expand that a bit. So this is a figure from a scientific paper a few years back. And they influence our behavior to a much greater extent than these areas can in a chimpanzee. So most of us fly in large tin cans, and we complain bitterly about being squashed like sardines, but we mostly keep our temper. We mostly, despite the instances of air rage, we mostly sit quietly, look at our screens, or read our books, or do whatever we're going to do. Now, I'd just like you to imagine as a thought experiment, what would happen if you could cram 200 chimpanzees into a modern airliner? And how long do you think it would last before chaos and pandemonium descended? Chimpanzees don't have the same kind of very strong impulse control that makes our kind of civilization possible. And what they lack is the strong connection between these ventromedial areas and the amygdala, which we have. And that enables us to maintain impulse control over much more stressful situations. But it also means that we are much more influenced by the activity in these ventral and medial regions than, let's say, a chimpanzee or another animal would be. And what do those regions participate in most? Well, we're still finding out, we're still researching, but they have a lot to do with social relationships, with especially long-lasting social relationships. They're a key part of the default mode network, which I showed you before. So they're certainly involved in whatever's happening when you're ruminating. But in particular, they're involved with feelings of obligation, of duty, of perhaps of grief, of loss. What would happen if you lost your spouse or lost a child? Thinking about that will activate your ventromedial prefrontal cortex. If you are thinking about something you've done to hurt somebody you care about, that guilt feeling activates the ventromedial prefrontal cortex. So that seems to be something unique to human beings that is a key to our kind of consciousness. This intense involvement with close relationships. And what's interesting and unusual is that we have a special kind of neuron. It's present in other animals as well, but there's many fewer of them. And in us, these special kinds of very fast neurons, you can think of them like internet cables in the brain, or They run largely from the social brain areas to a number of other areas, including all of these hub areas that I talked about. And we can only guess at what information is conveyed, but it seems plausible that our social values, our relationships that mean the most to us, are informing all of the activity of all of the other regions of the brain, and that to a much greater extent than any other animal. So I'm going to suggest that perhaps this gives us some idea of how human consciousness may differ from animal consciousness. So I'd like to end with a brief discussion of where I think we're going and why I think it's going to help. So I'd like to start with technology. We're very slowly getting better at measuring activity in the human brain on rapid time scales and seeing these shifting alliances between different brain regions. Right now, it's possible to record from a few hundred individual neurons in one human brain region. We don't expect anytime soon to be able to record from many neurons across the human brain. That's probably not going to be ethical with any technology we can imagine. On the other hand, we can certainly imagine the kind of technology that will enable us to record from many, many areas simultaneously at a very fine level in an animal, such as a primate or a rodent. Some of you have heard of Elon Musk's neural threads. There are a number of academic researchers working on similar technologies. So I think we will very soon have at least detailed recordings from the minds of monkeys as they engage in activities we might think of as close to human consciousness. But then how is this going to matter? I think that one thing it's going to bring to us, or at least to our descendants, is a sense of humility. If we understand the limited capacity of our conscious minds, and if we understand more about how our close relationships bias our consciousness and the workings of our brains toward the people who matter to us, then we may be able to discuss, or our grandchildren may be able to discuss, the kinds of political problems that seem now intractable, in a much more sophisticated manner. And I'm really hoping that as we understand how much of what we think of as obvious, the meaning of a situation, the things we can see, depend on our history with other people who have pointed those things out or who have influenced our consciousness, that may help us have some humility in the face of disagreement, which I think is something we could all use and is consistent with the aim of liberal religion as Joyce outlined it right at the beginning. And that's all from me, folks. Thank you for your attention, and I'll turn it over to Joyce now.
And can you quit sharing your screen? There we go. Well, thank you, Mark. I'm going to give you a break while I make a few announcements to the group, and then we'll bring you back for some questions. Okay?
Sounds
So
good.
take a break. I want to share my screen. And ask for your support. As you know, NAUA is a member service organization dedicated to supporting and promoting the practice of liberal religion by embracing freedom, reason, and tolerance, rooted in our commitment to the inherent worth and dignity of every person and all people. If you are willing and able, I'm going to ask for your support for NAU in a one-time donation or a recurring pledge. You can go directly to the website, naunitarians.org/support us, or if you are technologically able, you can click on this QR code on the right and it will take you to a donation page. I also wish to tell you about what's coming in NAUA programs. This weekend, the monthly worship is by Reverend Alex Holt. His sermon is Welcoming the Stranger. And I can speak to that because he gave this is a reprise of a sermon he gave to our Salish Sea Fellowship recently, and it was great. So I can definitely, I'm going to tune in again. I think you will enjoy him. The NAUA Book Club on October 23rd at 4:30 p.m. will be discussing a book, Crazy Like Us, The Globalization of the American Psyche. The NAUA Conversation and Discussion Circle is coming Thursday, November 5th at 4 p.m. And I want to remind you that on November 2nd, I think it is, we go back to standard time. So you'll be moving your clocks back. So pay attention to that. So that's we're in November and standard time. Then our next NAUA Academy program, Tuesday, November the 11th, 4:30 p.m. again on standard time, Pacific Standard Time. This is going to be Reverend Dr. Todd Eckloff speaking on one of his favorite subjects, the life and ideas of John Hassler Dietrich, mystic, humanist, and Unitarian. You may know that Reverend Dietrich was the minister of his Spokane church back in the day. I can't remember the time, early in the 1900s.
Early
And
1900s, yeah.
Early 1900s. And thank you. So that should be a good program. We hope to see you then. Okay, let me stop sharing and come back to Mark. And for those of you who have a question or comment you want to make, would you raise your hand? Thoughts, questions?
So happy to take questions about any aspect of the talk. Go ahead, Stephen.
Well, one of the questions that I would have is, are brain activations genetically similar within families, within relatives? And to what extent are activations to a specific stimulus genetically controlled or influenced by experience and environment?
Those are complex questions. The short answer is yes, family members, especially identical twins, do resemble one another much more than people who are taken at random. So that if you, from the population, so if you were to, take you and I and put us both in scanners and have us do a variety of tests, you could record your individual brain print and my individual brain print, and a computer now could identify us from among thousands of brain prints like that. And two very closely related individuals, like identical twins, will have much more similar brain prints than you or I will. So there's certainly a genetic component, but it's not genetically determined because identical twins typically diverge anywhere from, they may be consistent, maybe anywhere from 60 to 90%, but they're certainly not 100% consistent. Now, as to specific stimuli, yes, there is a genetic component to, let's say, sensitivity to sound or to light, but it's not, again, not very strong, and we certainly can't easily predict, precisely what our children's sensitivities will be. So, which is typical of most genes and behavior. There's some effect, but it's not everything.
Joanne, I think, has her hand. Oh, well, Terry first, perhaps. No, Joanne, sorry.
Okay.
Joanne, can you unmute? Yeah.
Yeah. Can you hear me?
Yes.
So my question kind of goes back to what you said, Mark, about, well, animals don't have as many connections. Are they as conscious? I'm thinking, like, if you're a human being and you're not conscious, you can't survive, right? So how are animals surviving, like our pets, if they're not conscious? Because if we're not conscious, we can't eat or take action, or really, we wouldn't be able to survive. I'm just trying to figure out how it could be possibly different for animals.
So this is an issue with the definitions of consciousness or the way that people use it. So you remember some people were using it just as awareness of the world around you. And certainly animals have that kind of consciousness. Some philosophers call that so-called primary consciousness. You're just aware of the world around you. What we're more interested in is the things that we think make us have a subjective experience, like what memories we have, what meaning we attach to things, what inner dialogue we have. And for those things, I think that the greater, you know, core connections, and especially the strong social brain connections, are playing a critical role in human consciousness that they don't seem to play in, let's say, cats or dogs, who are certainly aware of the world around them, often more aware of some aspects of the world than we are, such as smells or sounds. But they don't seem to have the kind of reflection or inner dialogue as far as we can measure. The animal behavior people who study dogs, work with dogs, say that dogs don't really feel guilt. They may feel apprehensive when they think, they correctly anticipate you're angry and you're about to punish them, but they don't seem to have any guilt when people take cameras of them tearing up the house when they're gone, when you, the owner, are gone. They show no evidence of anything remotely like remorse. So those, and again, there's many other uses of consciousness in between those two. And I'm just saying that it seems, I fully agree with you. They have some sort of awareness of the world around them. They don't have, as far as we can tell, remorse or guilt. They may have different mixtures or different aspects of consciousness to a greater or less degree. But consciousness is a many splendored thing, with many meanings in many situations. So rather than think, is it a light switch that's turned on or off? We should think of it as, a light that may have many different radiances, many different hues. And animals may have, some of the more gray and, and blue ones, but they still have something.
Thank you. Let's go on to Terry. And Terry, should we be stopping the recording?
Well, I think that people might be interested in these comments, so
Okay.
let's keep it open.
Carry on then. We usually do, but
now I've
let's do.
Set the standards high for my own question. Mike is mostly just a comment that we've been reading in the popular press. The question is AI conscious, and certainly it's what you just answered, Mark. It's no doubt that AI can be made aware of its context like a dog, but I can't imagine AI feeling guilty. So by that definition, it isn't. But I guess what I come away from is the fact that it's kind of a stupid question. Is AI conscious? Unless we have a clear understanding of what we mean by conscious to answer that question. So mostly just a comment. But thank you, Mark.
Sure.
Presentation.
I don't think that there's no possibility that any AI could be conscious. I think that might happen, but I don't think any of our current AIs are anywhere close to being remotely conscious. Who's next?
Thank you. Lorraine.
Yes, hi. I apologize in advance. This question is really going to come from left field. Many decades ago, I got a hold of a book by a a university professor of some kind named Julian Jaynes called
Oh yeah, the breakdown, the origin of consciousness and the
Origin of
breakdown of the
Consciousness.
bicameral mind.
Yes,
Oh,
and
wow.
I understand it was not ever taken particularly seriously by scientists and has largely been debunked, but it was a huge amount of fun to read.
Oh, it
But
was. Yeah, I remember that book. Yeah.
remember that? But I don't recall that he ever established that the that that the two halves of our brains did used to be separate and unable to communicate with each other, which is part of the
Yeah.
start of
So,
premise. Do you know anything about that?
well, we certainly can look at the connectivity of our brains and of chimpanzees' brains and of other animals. There's always a cross connection between them. Um, we actually have a little bit less cross connection than chimpanzees do. That's true. That was not known when Julian Jaynes was writing his book. He was very speculative. He was more grounded in mythology and taking particularly the Iliad and the Odyssey quite literally. Um, I, you're right that neuroscientists today don't take it seriously. Um, I think it was an imaginative attempt to point out something about the difference in experience if you do take the reports of the Iliad or the Odyssey or even, the Gospels, for example, seriously. People had a different way of experiencing the world, 2 or 3 thousand years ago than they do today. That's maybe something worthwhile to try to understand. Whether it resulted in any changes in biology, we don't think so. There's no evidence for that now. Thanks.
Thanks for that, Lorraine. Rob?
Yeah, I like the idea of dividing things the way E.O. Wilson did between transcendentalist views of things and empiricist views of things. I tend to the empiricist side, but I think that when you do that, you don't have to necessarily limit yourself to the brain. I mean, there are a lot of theories of consciousness, and Mark you refer to a lot of them. Some of them would say that the mind is a lot bigger than the brain, and some of the experiences of the people who are doing extreme sports and what seems to be a muscle thing and not a brain thing at all in response to the environment. It just seems to me that one can expand one's view of consciousness to a larger framework than the hub that the brain is. But I don't know. Just
Well, I think that, as I said, your relationships, which are, of course, with people outside of yourself, outside of your head, are an important part of your human consciousness. And so, in that way, I think you could say that our consciousness extends beyond our bodies, but that's a very limited and metaphorical sense. I think that the actual quality of my experience, which of course may be affected and is crucially dependent on my relationships, the actual sensations and feelings are arising entirely within the molecules of my head. So both can be possible. I don't think that there's any evidence for, let's say, direct mind-to-mind communication or direct access to the universe, but that's, of course, a controversial issue. But we can come back to that. Okay, I think Alexis is next.
Yes. Unmute, Alexis.
Okay, I've unmuted. Hello, everyone. Hi, Mark. I'm just reading this book, and I just want to read a couple of quotes from it, really short. I just like your thoughts on it. It's a book written by Robert Spolsky, Determined.
Oh, yeah.
Yeah, and he says here, just a moment, lost it. We are nothing more or less than the cumulative biological and environmental luck over which we had no control that has brought us to any moment. And then also, there is no free will, and thus holding people morally responsible for their actions is wrong. So, as far as I understand what he says, as far as I've read in the book so far, is that we do things unconsciously. We are not conscious. We think we're conscious of what we're doing, but it is already being put into motion by our brain, and that has come first, and that we are operating on some kind of delusion by feeling that we're actually navigating any situation. I was just curious as to what you think of that.
Well, I disagree with Sapolsky, whom I otherwise admire. He writes well and about many interesting and important things, but I think he's pretty much dead wrong about free will and moral responsibility. That's a very big topic. I have actually another YouTube talk on that topic.
Okay.
But it's, I would say that the simple, I shouldn't say that. You know, it's a simplistic argument to say, well, if you could know all of the motions of all of the molecules in my head, you could predict more or less what I'm going to say in the next little while. But as we have found out from, let's say, weather prediction, it's not really so simple as that. That we may be able to predict the motions of the planets for eons ahead, but we can't really predict the weather for more than a week ahead. And the reason is that small differences that may, be undetectable to any of our measuring instruments end up resulting in large differences many, many weeks ahead. And so in practice, that kind of determinism can't really work for a complex system like the brain or like the weather. Now, we might agree that there's probably better ways to handle criminality than putting people in prison. And I would agree with him about that. But I don't think that the notion of responsibility is vitiated for that reason. I think that, in fact, the notion of responsibility and expectations has been critical in the evolution of the human brain. I think we have this massive ventromedial prefrontal cortex precisely because we've had to come through for each other in times past. We live in an unusually individualistic society, the most extreme individualist society that has ever been on the planet. We are really the weird ones. If you like to read a book on this topic, Joe Henrich's book, The Weirdest People in the World, that's about us, contrasting us with normal people, who have lived in most other societies who are not nearly so individualistic and for whom the give and take of expectations and social obligation is part of the warp and woof of their everyday lives. And that's the world we evolved in, the world that our brain was evolved to take on. And I think we do ourselves a disservice in thinking that the way we live now is in any way intrinsically normal. That's much more of a long-winded answer. I'm sorry. I don't know of a short-winded answer.
Interesting question, though. Thank you. Let's hear from Gail.
Yeah, well, thank you, Mark, for your really interesting overview. My question really revolves around the issue of faith. And it's the issue of process theology and the embrace of Mark Levin's work, and you're probably aware of it, where he is working on cellular consciousness. Now, a lot of folks say, well, that's not awareness, but he is demonstrating that there's goal-directed behavior, there is cooperation at a cellular level. and those that embrace process theology, which is kind of an interesting movement, and it has penetrated all faiths from Christian to Buddhism to Hinduism, is that it is the creative process that is part of us or the universe. And I'm just wondering, what is your take on consciousness at a cellular level?
So I think that you can certainly say that cells respond to their environment, and they respond in ways that sometimes seem intelligent and often appropriate to us as observers. But that is, as Richard Dawkins argues very well in his books on the blind watchmaker, that these are things that have worked for ancestors of these cells in the past. The others didn't survive as well, and so we're left with cells that react in ways that are appropriate and that may seem intelligent. So I think that that's not a very good argument for anything like consciousness on the parts of cells. I think it is an argument for there being, it being easy to evolve something like intentionality. But again, that's also like Alexis's question, one of those questions that you could go on, for days talking about. So maybe I'll avoid being so long-winded and
Thank you. Thank you for your response.
Thank you for the question, Gail. Joanne, I think you get the last question here.
Okay, so you talked about neural excitation and inhibition. I thought that conversation was really interesting. How does our consciousness and our neural excitation and inhibition change with age, starting from when you're born to you get older? Are there changes that scientists are aware of or that you've found in your research?
That's a good question, Joanne. As you know, or maybe you don't know, but I certainly know, you slow down. Your thinking slows down as you get older. And lots of things are harder to access. Your neurons do change. They tend not to use energy as efficiently. A lot of them die. You have lots of them, so you can go for a ways before you notice that a lot of them are dying. But you do lose both the quality and the quantity of your brain as you age, and of course, different people lose more. Coming back to excitation and inhibition, one of the common observations is that people in their 70s or 80s often have fewer of these inhibitory interneurons, or they seem to be losing those preferentially. And that means that they can't sort of manage all of the complex balancing acts as easily as they could when they were younger. So there's lots of things that sort of don't work as well. They're not as graceful. They don't respond as well to feedback, just because we're losing those interneurons, those inhibitory cells specifically, or more commonly than the excitatory cells.
I think we've come to the end of our questions. And Mark, I want to thank you for taking this time with us. It was much appreciated. And I want to encourage all of you to come back with us in a month, November 11th, when Todd Eckloff will be speaking on Reverend Dietrich. So thank you.